All right, hello and welcome, future pharmacists. If you're hitting your third semester, you are about to get up close and personal with the real workhorses of pharmaceutical manufacturing. So today we're going to roll up our sleeves and get into one of the most fundamental machines you'll ever see, the ball mill. Let's get right into it and see how this thing works.
Okay, so before we get into the nuts and bolts, or, the actual steel balls, let's ask a really important question. Why on earth do we even care about grinding drugs into these superfine powders? Well, it all comes down to how well a drug can actually do its job inside the body. Think about it. The smaller the particle, the faster it can dissolve and get absorbed. For you, as a future pharmacist, understanding this is absolutely key to knowing how effective medicines are made.
So to make sure you've got this down cold, here's our game plan. We'll start with a basic principle, then we'll peek inside the machine, see it in action, check out its uses in pharmacy, and finally we'll weigh the good against the bad. The whole shebang, all in the next few minutes. First up, the power of powder. Let's dig into the actual physics of how you turn a solid chunk of something into a really fine, consistent powder. The entire operation of a ball mill really just boils down to two key actions: impact and attrition. And trust me, these aren't just some fancy words for your exam. These are the actual physical forces doing all the heavy lifting inside that steel drum.
Now, what's really cool is how these two forces work together. Think of impact as a powerful hammer blow. The balls get lifted up by the spinning mill, and then, bam, they fall and smash the material. Attrition, on the other hand, it's more of a grinding force. It's the friction you get as the balls rub against each other and against the drug, literally shearing it down. You absolutely need both for a really good grind.
Okay, so we've covered the how, the principles of impact and attrition. Now let's look at the what, the machine that puts those forces to work. It's time to take a look at the anatomy of the ball mill. This really shows you the simple genius of the machine. You've got this big, strong, hollow steel shell, and, critically, it's got a wear-resistant inner lining. This does two really important things. One, it protects the shell itself. And two, it prevents tiny bits of metal from getting into your final drug product. Super important. Inside, you've got your grinding media, the balls. A motor turns the whole thing, and then you just have a simple door to put stuff in and a simple hole for the finished powder to come out. Now this number here, 30 to 50%, this is super important. You might be thinking, hey, why not just fill it all the way up with balls? Wouldn't that be maximum grinding? Well, not really. If it's too full, the balls don't have any room to fall. They'll just kind of roll over each other. This sweet spot gives them just enough space to be lifted way up the side of the cylinder and then cascade down, creating that powerful impact force we were just talking about. So now that we know the principles and we know the parts, let's put it all together and actually watch the grinding in action.
It's a really simple continuous cycle. You load in your crude drug, the motor kicks on and the whole shell starts to rotate. As it spins, centrifugal force carries those heavy balls up the side until gravity wins the fight. Then they come crashing down, just pulverizing the drug through both impact and attrition. This just keeps happening over and over until the material is fine enough to exit through the outlet.
Okay, this is all great in theory, but where are you actually going to see the results of a ball mill in your career? Let's talk about its role in a pharmacist's toolkit.
The applications are just incredibly broad. I mean, from processing raw, natural stuff like plant roots and barks to manufacturing the powders for modern synthetic drugs. If you're making a liquid suspension, you need a super fine powder from a mill to make sure it doesn't settle out too fast. And if you're making tablets, you absolutely need a uniform powder to guarantee every single tablet has the exact same dose. The ball mill is behind all of it.
But no piece of equipment is perfect for every single job. So for your exams, and definitely for the real world, you've got to understand both the strengths and the weaknesses of the ball mill. Let's do a balanced evaluation.
And this lays it all out perfectly. On the plus side, it's really versatile. It can grind stuff whether it's wet or dry. And it's fantastic for really hard abrasive drugs that would just destroy other kinds of mills. But it's got its downsides. This is not a portable machine. It's a huge energy hog. And all that constant crashing and grinding means you're going to have to deal with wear and tear on the balls and the lining.
And this right here, this is the ball mill's biggest weakness. If you try to grind something that's soft, sticky, or fibrous, you are not going to get a fine powder. You're going to get a clogged up, gummy mess. That whole impact and attrition thing just doesn't work for those kinds of materials.
So that brings us to our final thought. We figured out that the ball mill is an absolute champion at crushing hard materials using impact and attrition. But what about those soft, sticky things? Knowing what you know now about its limits, what kind of principle, not just what kind of machine, what different principle would you look for to solve that problem? Something to think about as you move forward in your studies. Thanks for tuning in.